Good morning. So today we are modeling with quadratic functions. So we're just using functions with an x squared to help model some sort of situation. So our first one here says when an object is dropped, its height h in feet above the ground after t seconds can be modeled by the function h of t equals negative 16t squared plus h sub o, where ho is the initial height. So that's the height when the time is 0. So if we have negative 16t squared plus 200, that means the building has, or the object that's dropped has an initial height of 200 feet. So it's likely on top of a building or something like that. So it says this model also assumes force of air, gravity, all that stuff is already put in this. So it's a really good model for the situation. So it started at 200 feet, and then from there, started at 200 feet. From there, the object was dropped, and it took about 3.5 seconds to get down to the ground. All right, continuing on, it says 2 rock climbers try an experiment while scaling a steep rock face. They each carry rocks of similar size and shape up a rock face. One climbs to a point of 400 feet above the ground. So that's going to be important. The other to a place below her at 300 feet above the ground. So one's at 400 feet, one's at 300 feet. The higher climber drops a rock, and 1 second later, the lower climber drops his. Note that the climbers are not vertically positioned, so no climber is injured in this experiment. So for example, one climber is at 400 feet, and then the other one is maybe over here at 300, and then they each drop a rock that's falling. So we wrote equations for each of these using the equation negative 16t squared plus their starting height. So the first one is negative 16t squared plus 400. The second climber dropped his rock 1 second later, so he waited 1 second. So for example, if the first climber's rock has been dropping for 2 seconds, the other climber's rock has only been dropping for 1 second. Or if the first climber dropped his 5 seconds ago, the second climber dropped his 4 seconds ago because he waited 1 second. That's what this t minus 1 represents. It is waiting 1 second to drop their rock. And he started from a height of 300. So there's our equations, and then from there, so part B, assuming the rocks fall to the ground without hitting anything on the way, which of the 2 rocks will reach the ground last? Show your work and explain how you know your answer is correct. So for the first rock, this is the negative 16t squared plus 400. We're going to get a table. So you're going to use your calculator and go to y equals and get a table. All right, so type that in your y equals in the calculator and look at the table. I see 0 seconds. He's at 400 feet. After 1 second, the rock is at 384. 2 seconds, 336. 3 seconds, 256. 4 seconds, 144. And then 5 seconds, it's back to 0 height. And if the height is 0, that's when it hits the ground. This is first rock hits the ground. So now we're going to look at a table for the second rock and see if it's before or after this first rock. So remember your second equation. So this was at 5 seconds. Your second equation was negative 16t minus 1 squared plus 300. So I'm going to go to y equals and type that in. So negative 16x minus 1 squared plus 300. I'm going to look at the table. At 1 second, the height of the rock is 300 feet. Oh, wait. Yes, 300 feet because we're a second behind. At 2 seconds, 284. At 3 seconds, 236. At 4 seconds, 156. At 5 seconds, 44. And at 6 seconds in the table, I see negative 100, which the rock is not 100 feet below the ground, but at that point it has passed 0. So the rock reaches the ground between 5 and 6 seconds. Because at 5 seconds it was still above the ground, 6 seconds it's below the ground. All right. So then it wants to know which rock reaches the ground last. So the second rock is last. All right. Moving on, question C here. It says graph two functions of the same coordinate plane and identify key features that show that your answer to part B is correct. Explain how the graphs show that the two rocks hit the ground at different times. So we graphed the points from our tables here. H of 1 is our first table, H of 2 is our second. And it says the 0 for H of H1 is at right here, 5 seconds, while the graph of H2 hits the x-axis at like 5.25, somewhere in there. It can be an estimate. Either way, I know that it hits the ground after 5 seconds. So I know that the first one lands first. All right, on the next page, it says a monthly tea magazine has 28,000 subscribers when it charges $10, that's a 10, per annual subscription. For each $1 increase in price, the magazine loses about 2,000 subscribers. How much should the magazine charge to maximize annual revenue? What is the maximum annual revenue? So basically, it says the annual revenue is the number of subscribers times the subscription price. So we filled this in. Our revenue, R of X, is equal to our subscribers, our start, minus 2,000 for every $1 increase, but we don't know how many dollars yet. And then equals 10 plus, or times 10 plus X, $10 plus however much we increase it by. So they gave that to you. Then they also gave you the zeros and they gave you the axis of symmetry. What this looks like graphed is it's going to look something like this. And the axis of symmetry is going to help us find our maximum point, because this would be the axis of symmetry. So then our maximum revenue, that tallest point on the graph, is going to be our maximum revenue. So we know that it's going to happen when X is equal to 2. So we plugged in 2 here and solved it. And then we got 24 times 12. 24,000 times 12 is 288,000. So that means if they increase the price by $2, because X represented our price increase, so it's now $12, they will reach a maximum revenue of $288,000. So sometimes these functions are used to help estimate profits. All right, we're going to move on to the homework. Just like yesterday, I'll give you some hints to these problems. So it says Dave throws a ball upward with an initial velocity of 32 feet per second. The ball leaves his hand 5 feet above the ground and eventually falls back to the ground. So what units will be used to solve this problem? we're talking about feet and seconds, so feet per second. Write the formula for the height of the ball, h of t, where t is time in seconds, where we will use that equation from our notes, where it is negative 16 t squared plus the starting point of the ball, which is 5 feet. So our maximum height, you're going to find our vertex. And it says after how many seconds will it reach that height. So when you find your vertex, you can think of it as xy if you want, or t times our height. The first coordinate of the vertex will be our time. And then this should be your max height. So you can find your vertex using your calculator. You could find the vertex finding the axis of symmetry and then plugging that in. Either works. How long will it take for the ball to land on the ground after it's being thrown? Those are your roots. So remember I showed you how to find those in your calculator. So if you graph this and then you click second trace, which is that top row of buttons. So you click second trace, and then that brings up a bunch of options where you can find the 0. You could also find the maximum for the previous question using that. So choice 2 is zeros. And then remember you go just to the left and just to the right for each. So you do one root at a time. You can also, this is just negative 16t squared plus 5. So you could set it equal to 0, move the 5 over, divide by negative 16, and square root to get your answer. The next one, you're graphing it, so you use your calculator. And then fill in the pieces below. On the back, Katrina developed an app that sells for $5 per download. She has free space on a website that will let her sell 500 downloads. According to the research she did, a $1 increase in price, 10 fewer apps were sold. Let X represent each $1 increase and R of X represent the revenue. Use the model below to determine the price that will maximize her profit and the maximum profit. So this is kind of like the one about the magazine subscriptions. R of X equals our cost per download is $5 per download. However, it's starting at 5 and it could increase. So it could go up by $1, $2, $3, who knows. So plus X, because we don't know how much we're going to increase the price by. And all of that multiplied to the number of apps sold. So she is selling 500 apps, but then for every increase in price, she loses 10 sales. So that's going to be our equation. It says use the model to determine the price that will maximize her profit. So again, we're looking at a graph. We want to find the maximum. That is the vertex. So you can go ahead and find the vertex there. Number 3, I will let you guys skip this one. And that brings you to the end of your homework. So just a reminder, you have this homework to work on. You also have anything else in this packet or the old packet, because the old packet is due today. And you also have your Regents Review number 5 that's going to be due on Monday. If you have any questions, as always, send me an email. I will see you all on Monday.